Hey everybody, got a treat for you tonight. I hooked things back up to the point where they were inducing that static vibration at a distance, and been playing with some different receiving apparatuses. I'll show you in a moment. Same hookup, transformers are in parallel on the primaries, and the second, I'll show you the schematic on the board over here in a minute, but secondaries are wired in series so that they complement each other. Coming off of there, we're just going to, I just made a makeshift capacitor here. This is just an outer ring and a center ring that's not even hooked up. It's just jumped across to hold it together. And then off of that same outer ring to the primary, into series into the secondary, and series into the tertiary. And then this capacitor, just using the center rod. The outer ring here is not hooked up, and it's also coming off the same terminal as all the rest of the capacitors. About 4 inches, right about there, 5 inches away, I can feel my hair standing up. I can feel this vibration. It seems like 60 hertz affecting my skin, because it doesn't really look like my hair is standing up as I get really close, but I can feel the vibration. Same is true coming from the coils up here, and especially down here. Very strong coming out of here. It's very similar to the effect with the wood, like I'm feeling it come through the wood here onto my fingertips, and I'm sure we would see some plasma if I had the lights off. So I've been playing around with to see how far I can get this dome here to stand up away from the source over here and still produce the vibrations, because that's technically the only way I have to measure it right now. I can see voltage increasing and stuff, but I'm more interested in those vibrations. So I was able to get it all with the current setup all the way back to almost 7 feet. This pole stands 6 feet, this dome's 7 feet away from the table over there. And the strangest thing is when I have this completely unhooked, this dome here has no vibration. Now I don't know if you're going to be able to hear it, maybe when it's hooked up, but there's no vibration at all on this dome. When I hook this wire here up to the receiving waveguide coil, and I've got another dome hooked to that too, and that's going down to a second earth rod. Now I forgot to mention, the first earth rod is hooked to the bottom of those two secondaries there, and it's running over here 10 feet across the garage door. On the other side, outdoor, is the other ground rod, that yellow wire coming through down here, and it's going to the bottom of this coil. Now when that's hooked up, the effects are increased significantly. It also has an effect on whether I'm standing on the cement here or insulating myself on these rubber pads. I can feel the vibration moderately strong here and significantly strong here. So it got me to thinking about potentially how magnetic weight plays a factor in inductive coupling, and I wondered why doesn't then dielectric weight affect electrostatic coupling. So this is interesting. I've never been able, this is the farthest away that I've been able to get it. I see it's not working because I'm on the ground here. Farthest away I've been able to get it, I still have an effect. I can get about another foot or two, and it seemed to die out earlier. And this one really strong, so I can probably get a little bit more out of it. So that's the first setup. The next, I'm going to show you the schematic now. And this is what we got. This is the configuration. The two primaries in parallel, 120 running into them. Secondaries are wired together. One is going to earth. I have 3 earth rods in play here. A, B, and C. And I'll show you those in a second. So the first one's going to A. The top is coming over, like I showed you, is hooked to the one terminal of each capacitor. And up to 4 inches away, I feel this radiative vibration. And then I forgot to draw my tertiary coil on here, but you get the gist of it. I have three coils in series, and they're all radiating. On top of the top one is a small chamber where the terminal here is not actually touching that copper pipe I have the light bulb sitting in. So there's an air gap there, and essentially we're transferring plasma between the two to the outer bulb. Now, this is the setup that is 6 to 7 foot away, showing the dome, the 12-inch dome, the 4-inch dome, and how it's reacting. Strangely enough, if I hook a ground wire straight to that dome, it absorbs it all, and it's dead. There's no vibration whatsoever. But just because of the fact I have this ground wire hooked through that giant coil, a 4-inch coil spring, it's just a spring, and touching the bulb, and I still get the vibration. Stronger than I do when the dome is completely unhooked to anything or insulated. Over here I'll show you in a second, we got the tape hooked up between the house ground and earth rod C, which is 20 feet away from either of the two that are over there. And we've got an amp meter running on there, and I've got an LED hooked up. So I'm going to show you that here now. Give me 1 second. Okay, we're back. Apparently it blew out an LED while it was sitting there. Here's the Tate circuit, and the earth ground coming from the chassis here and the ground rod going to the bottom of the Tate, coming off the output through the galvanometer and into the LED. Which, well, first I'll show you when I'm shorting it directly out. The voltage fluctuates. I had a video on this yesterday. I was seeing all this weird fluctuation, but I couldn't light an LED with it at all. I couldn't do anything until I turned on the thing over there. Now it appears like it's blowing LEDs. I hook them up and I tap them just for a second, and they flicker and then they stop working. I can't imagine there's that much current because. Bear with me just a minute. Okay, before it dies, here's the LEDs lit. It's really bright when I first tap it, so that you can tell the Tate is building up some storage in there, and I'm discharging it, so voltage does drop down a bit, and it just burned out again. See, I touch it, the meter's still working. These LEDs are burned out. I ran this bulb through it to try to limit the current. Well, maybe it's shorted, that's why. Before it blew it out. So yeah, those are blown. It's blowing LEDs. It was staying lit for a while, but something even got more enhanced recently. But what's weird is like, I realize these are microamps, but I'm still getting fluctuations with this bulb here in series. This is a 24 volt 150 watt bulb, and it's hooked in series off the output, the DC output of the Tate, and you're still reading 100 to 200 microamps as it fluctuates. Obviously it's not a whole lot higher when I directly short it. 125 maybe. Still, see, I was hooked back up and it's still at 125. So there's really no drop in current based on the resistive load. The same with inductive. I don't get any detectable voltage drop from it. But this is really, really interesting. I hope you can make that out. I need to put my tertiary in there. And the primary here. All three of which radiate this electrostatic pulse.